Hello students, this is Vijaya Ushir. In the last lecture, we have studied about the Langmuir adsorption isotherm. So, in this lecture, we will study the adsorption of gases by the solid and the factors affecting on the adsorption. So, all the solids can adsorb the gases to some extent. Means, we have already studied the two types of adsorption isotherm, that is Freundlich adsorption isotherm and Langmuir adsorption isotherm. So all these solids adsorb the gases to some extent, and the characteristic feature of all these adsorption and the factors affecting the amount of gas adsorbed by the solid are given below. And the first factor affecting the adsorption is the nature of adsorbent. So, what happens if the surface area of the adsorbent is large? The adsorption is extensive. So, this is a simple fact that if the surface area of adsorbent is large, therefore, more number of molecules get adsorbed on the surface of adsorbent. Therefore, we can say that the adsorption is extensive, means the adsorption can happen in larger proportion. And for this reason, the silica gel and charcoal are particularly effective as adsorbing agents. Means the silica gel and the charcoal provides a very good surface area for the adsorption and effective as adsorbing agents. And these substances have, the silica gel and charcoal have a very porous structure. Means they have very porous structure, means they have small pores on their surface. So they can adsorb large molecules by providing large surface area, and which is available for the adsorption of gases. And more finely divided or rougher surface of the adsorbent leads to the large adsorption. Means if the surface of adsorbent is finely divided, means we have already studied that the surface area provides the large surface of the adsorbent for the adsorption. So, more finely the divided or rougher surface, the adsorbent leads to the larger adsorption. And the extent of adsorption is also increased by activating the adsorbent. Means the rate of adsorption is always also increased by activating adsorbent. So what type of activation we can do? So by heating the substance. So what happens due to heating? To improve the heating improves the adsorption by removing impurities. Means if we heat a substance, then it can remove the impurities. Therefore, the rate of adsorption increases by providing the more surface area. So this is the first factor affecting the adsorption, that is the nature of adsorbent. The second factor affecting the adsorption is the nature of gas. So the gases which are easily liquefied, means they have high critical temperature, and the gases which are highly soluble in water are adsorbed to the greater extent. Means the gases which are easily liquefied, having high critical temperature, and the which are highly soluble in water are adsorbed to the greater extent. For example, volume of chlorine by 1 gram of charcoal at 15 degrees Celsius and having the critical temperature, that is 417 Kelvin, which is a very high critical temperature. And by 1 gram of charcoal, the volume of chlorine adsorbed at 15 degrees Celsius is about to 235 centimeter cube, and that is the very large amount. So only 1 gram of charcoal at 15 degrees Celsius is responsible for adsorbing about the 235 centimeter cube of chlorine. So this is the very large factor, that is 235 centimeter cube. While that of the adsorbed nitrogen. So for the nitrogen, that is the critical temperature for the nitrogen is 126, means very low critical temperature. By same amount of charcoal, means same amount of charcoal, if we use 1 gram of charcoal, but instead of chlorine we can use, if we use the nitrogen, so the adsorbed gas is at same temperature, means the at same 15 degrees Celsius, the adsorbed gas is only 8 centimeter cube. And here if we see the factor, that is 235 centimeter cube, and the difference between 235 and 8 centimeter cube is very large. Means if the critical temperature is higher, so the gases can be easily liquefied, that is they can easily converted into liquids into gases, so they can be easily adsorbed on the surface of adsorbent. So nature of the gas is very important factor for determining the rate of adsorption. So this is the second factor affecting the adsorption. So third factor is the temperature. So what does the temperature? So extent of adsorption varies inversely as temperature. So lower the temperature, higher is the adsorption. And for this reason, during the creating a perfect vacuum, animal charcoal is used at a liquid air temperature. Means the effect of temperature on the rate of adsorption is the inversely proportional. Means as the temperature increases, adsorption decreases. And for this reason, to create a perfect vacuum, animal charcoal was used as at a liquid air temperature. And from this, it can be concluded that heat must be liberated during the adsorption, because the adsorption occurs at more amount of adsorption occurs at low temperature. Therefore, it can be concluded that heat must be liberated during the adsorption. Fourth factor affecting the adsorption is the pressure. So, initially what happens? The initially adsorption of gas molecules by the solid increases with pressure. But when the unbalanced field of force of adsorbent gets saturated due to the adsorption, any further increase in the pressure has little effect on the amount of gas adsorbed. Means initially what happens? As the pressure increases, adsorption increases. But if unbalanced field of forces is present, means the forces are unbalanced. So what happens? The surface of adsorbent gets saturated due to adsorption. Means all the surface is adsorbed by the adsorbent molecules, and any further increase in the pressure has no effect. Means if the surface of adsorbent is completely saturated, means completely covered by the adsorbent molecules. So if we increase the pressure, it has little effect on the amount of gas adsorbed. Fifth factor affecting the rate of adsorption, that is the reversible nature. Means in the adsorption, an equilibrium is established between the gas in contact with solid and the gas on the surface. And for this surface, for a given system, the extent of adsorption under any condition of temperature and pressure is definite and reproducible. Means we have already studied that the adsorption is an equilibrium process. So the adsorption and desorption takes place simultaneously. So equilibrium is established between these two processes. So for this purpose, for a given system, the extent of adsorption under any condition of temperature and pressure is definite and reproducible. And establishment of this equilibrium indicates that adsorption is a reversible process, and the adsorbed gas molecules can be recovered by raising the temperature. Means rising the temperature or lowering the pressure. Means the adsorbed molecules can be recovered, that is desorbed by raising the temperature or lowering the pressure. So the removal of adsorbate molecules from the surface of adsorbent is called as a desorptions. Desorptions means D means breakdown, and sorption means the adsorption process, that is sorbed molecule, that is they are stick on the surface of adsorbent, and desorption means breaking of this adsorbed molecule, that is the desorption process. Sixth factor, that is the exothermic nature. So we have already studied that adsorption is a heat is liberated during the adsorption process. Therefore, it is an exothermic reaction. So it is an exothermic process and heat is evolved in an adsorption, that heat is called as a heat of adsorption, because the process is adsorption process. Therefore, the heat evolved in this process is called as heat of adsorption. Seventh factor affecting the rate of adsorption is the specific nature. So, the adsorption of gases by the solids may be selective. From the mixture of ethylene and coal gas, charcoal adsorbs only ethylene. Means the adsorption has a very specific nature. If we study the adsorption of gases by solids from the mixture of ethylene and coal gas, that is a charcoal. So, from the mixture of ethylene and coal gas, if charcoal is used as the adsorbent, this charcoal adsorbs only ethylene and not the coal gas. This is called as specific nature. Means this charcoal specifically adsorbs the ethylene and not the coal gas. So, these are the 7 factors affecting the rate of adsorption. So, next part is the adsorption of solutes by the solids. So, the adsorption of solute from the solution of a solid can be illustrated by following examples. So, first is when the solution of acetic acid in water is shaken with the activated charcoal, a part of acid is removed by charcoal adsorbent and the concentration of solution is decreased. Means when the solution of acetic acid in water is shaken with activated charcoal, so what happens? The part of acetic acid is removed by charcoal, means that is adsorbed, and the concentration of solution is decreased. Second example is the decolorization of sugar solution by activated charcoal. Third example is the removal of ammonia from the ammonium hydroxide solution by the activated charcoal. So, all in this example, this activated charcoal works as a adsorbent, and the removal of ammonia from the ammonium hydroxide solution by the activated charcoal. Next example is the separation of various components of mixture by aluminium oxide or silica gel. Means the separation of these various components of mixture by aluminium oxide or silica gel, as in chromatographic separation. Means in the chromatographic separation, we separate the mixture, and that is the purification of water by activated charcoal. So, the purification of water by activated charcoal, all these are the adsorption of solutes by the solids. The removal of phenolphthalein from the solution of acids or bases is also done by the activated carbon. So, in the acid-base titration, we always use the indicator, that is phenolphthalein. So, what happens? Due to this phenolphthalein, the solution becomes pink colored at the end point, that is titration end point. So, the phenolphthalein can be removed from the solution of acids and bases by using the activated carbon, that is activated charcoal. Also, the adsorption of silver or chloride ions from the solution of freshly precipitated silver chloride. The adsorption of sulfide ions from the solution by arsenic trisulfide. This is also the example for the adsorption. So, these are all the examples of adsorption of solute from the solution by solid. So, first is the solution of acetic acid is shaken with activated charcoal. Second is the decolorization of sugar solution. Third is the removal of ammonia from ammonium hydroxide. Fourth is the separation of components of mixture by aluminium oxide or silica gel. Removal of phenolphthalein from solution of acid-base titration. Adsorption of silver or chloride ions from the solution of silver chloride. And last one is the adsorption of sulfide ions from the solution by arsenic trisulfide. And in all these, which is used as adsorbent, that is activated carbon or activated charcoal. So, the adsorption of solute from the solution by solid rises due to decrease in the free energy of the surface, and this results in higher the concentration of the solute molecules on the surface of solid than that in the bulk solution. So, what happens due to the adsorption? The adsorption of solute from the solid due to decrease in free energy. So here the adsorption, in the adsorption process, the free energy decreases. Therefore what happens? Higher is the concentration, higher the concentration of solute molecules on the surface of solid than that of the bulk of the solution. So the component which has high capacity to lower the surface tension, means the component which can responsible for lowering the surface tension of the adsorbent will get concentrated on the surface, and such substances are said to be surface active because they have capacity to lower the surface tension of adsorbent and get concentrated on the surface. Means they get concentrated, the components which get concentrated on the surface of adsorbent, these substances are called as a surface active substances. And on the other hand, if the solute causes to increase in the surface tension, its concentration on the surface will be less than the remainder, and this phenomenon is called as a negative adsorption. So on the other hand, what happens? If solute molecules increases the surface tension, so its concentration on the surface of adsorbent will be less. Therefore what happens? This phenomenon is called as a negative adsorption because adsorption is decreases, which is called as a negative adsorption. And in short, we can say that in this phenomenon, the concentration of solute is actually increased after the treatment with adsorbing agents. Means the concentration of solute is increased after treatment with adsorbing agent. For example, when a dilute solution of potassium chloride is agitated with blood charcoal, means when the dilute solution of aqueous solution of potassium chloride is agitated with blood charcoal, so what happens? Then increase in the concentration of solution is observed. Means increase in the concentration of solution is observed rather than the reduction. So concentration increases rather than its reduction because of decrease in the due to adsorption of solvent molecules on the surface of adsorbent. Means the dilute aqueous solution of potassium chloride is agitated or mixed with blood charcoal. Therefore what happens? Increase in the concentration of solution rather than its reduction, that is decrease, due to adsorption of solvent molecules on the surface of adsorbent. And the adsorption in solution solid system follows generally the principles and characteristic features laid down for the adsorption in gas solid system, and thus it is certain that extent of adsorption depends mainly on the surface of adsorbent available for the adsorption. Means the extent or rate of adsorption mainly depends on the surface of adsorbent which is available for the adsorption, and the process of adsorption is almost reversible and equilibrium is reached. We have already studied that the process of adsorption is reversible and equilibrium is reached in short time, and which that time is dependent on the concentration of solution and the area of adsorbent available for the adsorption, and this depends on the concentration and area of adsorbent available for the adsorption. Again, an increase in temperature causes what happens? We already studied the factors affecting the adsorption. The temperature increases, it decreases the rate or extent of adsorption, while increase in surface area of adsorbent increases the adsorption. And the empirical equation devised by the Freundlich adsorption isotherm also holds good and takes the form. We have already studied the Freundlich adsorption isotherm. What was the equation for the Freundlich adsorption isotherm? X upon m is proportional to C raised to 1 upon m. C is the concentration, N is the number of molecules, X is the amount of gas adsorbed per mass of adsorbent. So this proportionality sign is replaced by constant. Therefore, we can write X upon m is equal to K into C raised to 1 upon n. So taking log on the both sides, we can write this equation as log of X upon m is equal to 1 upon n into log C plus log K. And here C is the equilibrium concentration of solution. And if we plot the graph of log of x upon m on the y-axis versus log C on the x-axis, so this is the equation having the straight line. This is of the form y is equal to mx plus c. So what happens if we plot this? So we got a straight line, and it is observed that the Freundlich equation works better with this type of adsorption than the adsorption in gas solid system. Means the Freundlich equation works very better for the adsorption in gas solid system, for adsorption in gas liquid system than that of the gas solid system. So if we plot this log of x upon m versus log C, we got a straight line having the slope 1 upon n and having the y-intercept log K. So we can calculate the value of n and K from the straight line. So this was all about the isotherm from the solution, isotherm for the solution from the solids. So in the next lecture we will study about the BET, that is Bate isotherm for the reaction. So thank you.